Hello, my name is Adil, and today I'm going to be showing you how to transform trig functions. What do we need to know? So first, it's important to understand what each variable in our equation does. Starting off with A, which stands for amplitude, it is in charge of the vertical stretch or compression by a factor of A. And it is also in charge of whether there's a vertical reflection or not, depending on whether A is negative or positive. Second, we have K. Similarly to A, K is in charge of the horizontal stretch or compression by a factor of 1 over K, and it is also in charge of whether there's a horizontal reflection, depending on whether K is positive or negative. And one important thing to know is 2 pi over the absolute value of K will give you the period. This is important for just understanding your graph and being able to solve questions. Next, we have D, which is in charge of the phase shift, basically meaning it's in charge of whether the graph shifts left or right. Next, we have C, which is in charge of the vertical shift. Similarly to D, this is in charge of the movement, however this time it's vertically on the y-axis. So how do we do it? Make a chart of a parent function and apply transformations. So here are the points of our parent function, y equals sine x. I got the points for x and y, and based on our equation, which in this case is going to be 2 sine bracket 2 bracket x minus pi over 4 bracket bracket plus 1. So understanding what our variables are, we are going to transform and we are going to apply those transformations onto these coordinates in order to get a sketch of our graph. So for the x side, the transformations that are going to be applied to these numbers are going to be for x divided by 2 plus pi over 3. How I got this is by dividing our x value by our k value and adding our d value, which is our phase shift. Next, for y, I got 2y plus 1 by multiplying y by our a value and adding 1. After putting in each value into our equation, you are going to be left with these numbers over here. Using these, we can plot a graph of the transformed function. Now we need to verify. We can use Desmos to verify whether our points were accurate or not. Our first value is 2 pi over 6, which could be simplified to pi over 3. So now we're in Desmos, and I basically plugged the equation into Desmos just so we can see how it looks. Using our point x equals pi over 3, we can see that it has a y value of 1, and just like our graph, it also has a pi value of 1. Now if you check all of these points, 3 pi over 6, it matches up with the y coordinates on our transformed t-chart. So next we have 5 pi over 6, and as we can see, it has a y value of 1, just like our graph. Now we have 13 pi over 12, which is basically 6.5 pi divided by 6. Now looking at our graph, we can see that 13 pi over 12 has a y value of negative 1, matching with our t-chart. And lastly, we have 8 pi over 6, which could be simplified to 4 pi over 3, and we get a value of 1, just like our t-chart. So now you can see that all of our points match up. So how do we apply this to real life? So first, architects and engineers use trig functions to design buildings, bridges, and other structures. Second, in physics, sine and cosine functions are often used to model sound and light waves. For example, the amplitude of sound waves or the light intensity of a laser beam over time can be modeled as a sine function as shown in this picture over here. And lastly, in sports and kinematics, trig functions are often used to model the trajectory of objects in motion, such as in sports like basketball or football, where fewer distances are important in predicting the flight path of a ball. For example, to predict the best angle to launch a basketball to make a shot, you can use the sine or cosine functions to calculate the ideal trajectory. And that sums out just about everything on transforming trig functions. Thank you for watching, and I'll see you in the next video.